During a chemical reaction, either the heat can be absorbed or heat can be liberated. A boundary is an imaginary line which always separates the system from the surrounding, whereas the surrounding is a remaining universe which always have an interaction with the system. It is only the branch of chemistry where we are going to study about the different forms of energy and its interconversion and its use. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to discuss with a new unit called Thermodynamics, that is in your unit 6 on your first PUC Chemistry. Let's see the weightage of this unit. So from this unit, there is no 1 mark and a 2 mark question as well as with a 3 mark question, but directly we can expect the 2 5 mark question and totally it carries 10 marks. Okay, remember in the 5 marks, again the question can be divided into 3 plus 2 or 2 plus 2 plus 1. Okay, let's see what we are going to discuss in this session. In this session, we are going to understand the introductory part of the thermodynamics. Okay, and finally we are going to understand what are the types of system will be there in the thermodynamics, and we are also going to understand the thermodynamics properties. Okay, let's see what actually the thermodynamics unit is. So the thermodynamics, it is a branch of science where we are going to study about the different forms of energy and its interconversion. So what is thermodynamics? It is a branch of science where we are going to deal with the different forms of energy and also its interconversion. The best example is if you consider any chemical reactions, we know that during a chemical reaction, either the heat can be absorbed or heat can be liberated. So that form of energy, we can convert it into mechanical energy or electrical energy. This is how more about the energy and its forms and their interconversion, we can study it by a separate unit called as thermodynamics. Again, it is one of the physical chemistry unit. Okay. So the thermodynamics is a branch of science which deals with the study of different forms of energy and their interconversion. It is said to be thermodynamics. The chemical energy will be stored by the molecule, can be released as a heat during a chemical reaction, may also be used to do with the mechanical and can also provide in the form of electrical energy. The best example is when a fuel is like a methane or a cooking gas or a coal burns in air, when a fuel burns in an engine or the galvanic cell like a dry cell. These are the best example where the one form of energy can be converted into another form of energy and its utility, how we can interchange into the different forms of their utility, that can be studied by this unit. Okay, and thus the various forms of energy are interrelated, and under the certain condition, this may be transferred from one form to another form. That can be studied by using a thermodynamics. Remember, it is only the branch of chemistry where we are going to study about the different forms of energy and its interconversion and its use. Okay, let us understand now the different terminology which we are using repeatedly while studying with the thermodynamics. Okay, these are the thermodynamic terms. The first important term is a system or a system. Okay, a system is a part of universe in which observations are made. It is said to be what? System. For example, if I consider a glass of hot water, to that glass of hot water I am doing the observation. That is said to be what? System. It is a part of universe in which all observations will be made. That is said to be a system. surrounding, the remaining universe which can interact with the system and constitute the surrounding. For example, if I am studying a glass of water, okay, which is nothing but a hot water, okay. So I call this a studying of this hot water in the glass. It's said to be a system. Now, except this system, what is the remaining universe which is there? That is said to be a surrounding, because this surrounding can also be interact with the system, thereby it can involve many changes. We have one more terminology known as boundary. The wall that separates the system from the surrounding, it is said to be a boundary. It is a wall which separates the system from the surrounding. It is said to be a boundary, and it is always in the imaginary line. So I can rewrite this by taking an example. Okay, this is an imaginary line I am drawing. Okay, we know that this is a line which is separating the system from the surrounding. Hence, it is a boundary. So, what I said, the system is something we are going to study it. Correct, no? So, it is a system. What is surrounding? So, it is a remaining universe which keep on interacting with the system. Okay, this is how we can easily understand the differences between system, surrounding as well as with a boundary. Remember, a boundary is an imaginary line which always separates the system from the surrounding, whereas a surrounding is a remaining universe which always have a interaction with the system. Or you can say that the universe which is nothing but a system plus surrounding. Coming into the system, it is a part of universe where you are going to do all the observation for that. That is said to be a system. So, hope you all understood with the three important definitions which we are repeatedly using while studying about the thermodynamics. Which are those? One is system, surrounding, and the boundaries. So, system is a part of the universe where you are going to do the all observation. Okay. Whereas a surrounding, it is the entire remaining universe which have a interaction with the system. Or you can say that a universe which is equal to a surrounding plus system. Okay. Coming into the boundary, it is a imaginary line which separates the system from the surrounding. This is how we can easily remember the three important definitions which we are frequently using while studying the thermodynamics. Next, we are going to study about the types of system. We can easily classify the system based upon the two things. One is based upon the movement of the matter. Other one is based upon the how does the energy which is present inside the system or outside of the system. So, one is the movement of the matter, other one is the energy present inside or outside of the system. Based on these two criteria, we can classify the system into three types. They are open system, closed system, and isolated system. We'll see what is the open system and what is the closed system and also with the isolated system. First, I'll go with the open system. An open system is a system there is a exchange of energy and matter between the system and surrounding which is taking place. Such systems are said to be an open system. For example, if I add a test tube, to this test tube I am putting a hot water. Now, if you see that hot water, if you keep it on my table, what will happen? We know that hot water can easily get evaporated, thereby after 10 minutes it can cool. Correct, no? So, there is an exchange of energy which is happening. And also, there is an exchange of matter which is taking place. Such systems are said to be open system. Or you can convey this topic with our daily life also. The best example is if you take a cup of hot tea and if you kept it on my table, what will happen? After a few minutes, the entire tea will become cool. Why it has become cool? Because it is exchanging its matter. Or there will be a movement of the matter which is happening with the surrounding. That is why, there is a movement which is happening with the matter, and hence it is a open system. Meanwhile, the energy which is inside the system, which is going outside of the system, that is why it is an example for an open system. We have one more system known as closed system. You can see that in a closed system, we have taken a test tube where to that test tube we have added the hot water, but I am closing the lid of the test tube. What will happen and what we call such system then? Such systems are said to be a closed system because in those systems, the exchange of energy which is happening, but there will be no exchange of the matter which is taking place. Such systems are said to be a closed system. So, you are taking a cup of tea. To that cup of tea, you are placing a plate on the mouth of the cup. What will happen? There is a change in energy which is happening. After a few minutes, the tea will become cool. Such systems are said to be closed system. Remember, their matter is not undergoing any changes. There is no exchange of the matter which is happening. Such systems are said to be closed system. We have one more system known as isolated system. You can see that I am placing this hot water test tube in an closed container and it is isolated. You can compare yourself that you are putting a hot water in a flask, okay, that is a thermo flask. What will happen if you keep the hot water in a thermo flask? It will be hot only after 1 hour, 2 hours, or with 3 hours, 4 hours also. This indicates that these are the isolated system where there is no exchange of energy or nor with the matter which is happening between the system and surrounding. Hence, it is an example for isolated system. There will be no exchange of energy and there will be no exchange of matter which is happening. Hence, it is said to be isolated system. What we call for such system? Isolated. So, hope you all understood with the 3 important systems which will be considered based upon the nature of movement of matter and also with the energy. Next, we have the state of a system. The state of a thermodynamic system is described by measurable or with a macroscopic property. What are the macroscopic property then? They are, example, the state of a gas is described by its pressure, volume, temperature and also in the amount. The best example is, suppose, imagine I have taken out a closed container where I am placing the gas molecule and also it is closed. We know that each thermodynamic systems are affected by temperature, pressure as well as with the volume. Now, if I apply the pressure, what will happen to the volume? Volume will be decreased. If I don't apply any pressure also, the volume of the system will be increased. Correct, no? So, the pressure and the volume which is altering means indirectly the temperature is also altering. Correct, no? So, this indicates that the state of a thermodynamic systems are described in a measurable way. It can be in the pressure, it can be in the volume form or it can be in the temperature form. Next is state functions or the state variables. The variables like pressure, volume and temperature are said to be what? State variable or state function because their value will be depends only upon the state of a system, not on how much it has been reached. The best example again you can consider, I have taken out the a closed container. To this I have placed the gas molecule. We know that if I apply the pressure and volume will get changes from P1 to P2, V2. Correct, no? So, immediately if you change the temperature also, it can also change this from T1 to T2. This indicates that they are the state variables or the state function, because when you are applying the pressure, the volume is changing, temperature is also changing. When you are not applying pressure, you know, the pressure is also changing from its initial state to the final state. This indicates that they are actually depends upon the variable, not on that how much you are applying the pressure. Understood? It talks only about the state of the system, not on that how much you are applying the pressure. It just concerns only about the state of the system, initial state and the final state. Okay. Next we have the internal energy as a state function, and we call that internal energy as U. Okay, it is very much important to understand why we call the internal energy of a system as a state function. We'll see with an example. Internal energy is the sum of all the types of energy associated with the system. That is the total energy of the system, which is said to be the internal energy, and it may be in the form of chemical, electrical, mechanical, or with any other types of energy. It is said to be what? Internal energy, and it is denoted as U. I usually remember the internal energy as a total energy of a system, or it is a energy which is present inside the system. This internal energy of the system can also get changed only when the heat passes in or out of the system, and also the work is done on or by the system. And we have one more condition, that is the matter enters or leaves out of the system. So this indicates that the internal energy of that system can change only when the matter ends or it will be lasered. Only when the work is done or by the system or on the system. And lastly, when heat passes into the system or by the system, so or out of the system, that is only the three cases where the internal energy of the system is going to be altered. Then what is the internal energy? It is the total energy of a system, and it is present inside the system, and it is in the form of physical, chemical, mechanical, or with any other types. Okay. Next we have the thermodynamic property. When we are studying this thermodynamics, we have observed that there are three types of system will be there, and also all thermodynamic processes, they exhibit the two types of property. One is extensive property, and the one will be intensive property. So these two differences can be asked for 2 marks. In the 5-mark question, you know, one of the questions can also be asked like a define or extensive property or intensive property, or write the differences between the extensive and intensive property. These are the property which depends only on the quantity of the matter which is contained in the system. Example, the mass, volume, heat capacity, internal energy, enthalpy, entropy, gives free energy are the example. It is only meant only for the how much of the energy which is present inside the system, or how much of the quantity of energy which is present in the system. For example, if I am talking about the mass of a particular substance, or with the mass of that a substance, it may be 8 grams. Suppose if I am studying about a cup of tea, where I have taken out the 5 ml of milk, okay, or 5 ml of tea, okay, that 5 ml, that volume, it is where it exactly showing the quantity of the matter which is contained, you know, that property it is said to be extensive property. We have one more property known as intensive property. One is extensive and the one is intensive. These property which is depend only upon the amount of the substance which is present in the system. How much of the amount which is present. If it is expressed in terms of quantity, you know, that is extensive. Okay. If it is said in terms of amount, we say it is intrinsic property. Example, temperature, refractive indexes, density, surface tension, specific heat, freezing point and boiling point. For example, I have made my tea at a 90 degrees Celsius. How exactly I am telling the boiling point. Okay, so that is said to be a temperature, freezing point or the boiling point or melting point, they are belonging to the intrinsic property, because those property which are only depends upon the amount of substance which is involved or present within the system. Hope you all understood with this session. So in this session only I have done the introduction to the thermodynamics and what are all the common terminology which we have studied, and types of the system and types of the property, which is very, very important to understand with the thermodynamics. So in the next session, we are going to understand the types of thermodynamic processes. So I'll come back with the next unit. Till that, take care, be safe. Thank you.